looking at additional maths chapter 1, functions. So this is part 2 of the video. If you've not watched our part 1, please go back and take a look at chapter 1. Today we're looking at 1.4, 1.5, 1.6. Okay, so we'll be looking at the first one, 1.4, which is modulus of a function. The first one is the modulus of a function. The first one is the modulus of a function, and in modulus we is like the absolute value. It's like you find the magnitude. Okay, the way we find magnitude, for example, if they give you x and y, for example, they give you the force. They say force of an object, okay, has horizontal value and both horizontal and vertical values, right? So we can find the magnitude by saying this one will be, by putting this symbol like this. This is the symbol of modulus, which means magnitude, equal to the horizontal component of the force. You square it, the horizontal component square, plus the vertical component. You know, we use y for vertical as this. So we say plus the vertical component of that force or of whatever you are considering. And then you take the square root of it. This is how we find the modulus, or this is how we find magnitude of a number, of any given number, okay? So the magnitude, usually if you are given a number, if it's negative, if you find the magnitude of -3, if you find the magnitude of -3, it's going to be what? It's going to be what? +3. All modulus gives positive number. It's going to be 3. So ordinarily, it's going to be 3, right? So ordinarily, if we tell you that the modulus of a number is 3, it means the original number could have been +3 or -3. Because if you do for +3 also, you're going to get 3. If you do the modulus of 3, ordinary number 3, if you do the modulus, you're also going to get 3. If you do the modulus, okay, you're also going to get 3. You're also going to get 3. So if we're given a number, they say the modulus of a number is 3. They've given us the solution as 3. Then what's the original number? The original number could be either be -3 or +3. The original number could either be +3 or -3. Meaning all absolute value, because modulus means the absolute value. All absolute value or all modulus of a number, the original numbers are plus or minus. Because when you do plus or minus, it's like you put a bracket in your calculator. You say -3, you open a bracket, you put -3, and then you square it, you're going to get positive number. That's the same meaning. That's the same meaning. Okay? So, okay, now let's take a look at an example. Let's take a look at an example in this regard. Let's take a look at an example. For example, the first one, is the modulus of 4x plus 3 is equal to x plus 18. The modulus, so let's solve this one. The modulus of 4x plus 3 equals to x plus 18. So I have 4x. I have, okay, let's redraw this. Started lagging again. Okay, we can use, if it's not helping us, we can use, like, let's use the highlighter. Okay, now the modulus of 4x plus 3 is equals to x plus 18. So what you do, you know modulus, they give you this the modulus by putting 2 lines here, right? So it means 4x plus 3 equal to x plus 18, or 4x plus 3 equal to minus x minus 18. Why? Why do we say equal to positive? You remember we say whatever gave this one, because you say this one gave this one. X plus 18 equal to this modulus 4x plus 3. So these numbers, or this algebra that gave this rise to this modulus, could either be plus or minus. So in the first scenario, we have x plus 18, which is the positive one. In the second scenario, we have minus s minus 18. In the second scenario, we have minus s minus 18. So you go to solve them separately and get 2 separate answers. We go to solve them separately and get 2 separate answers. So which means if we take 4x plus 3 equals to 18, you bring x to the left. It becomes 4x minus x. You take this 3 to the right. So it becomes 18 minus 3. Right? 4x minus x becomes 3x. That's how we got this 3x. That's how we got this 3x. And then 18 minus 3 will give you 15. 18 minus 3 will give you 15. So you divide both sides by 3 in order to get there, to get our x. So you divide here by 3, you get x. You divide this 15 by 3, you get 5. So s equal to 5 in the first scenario. Now, remember, because it's a modulus, you're going to do equal to plus x plus 18, and you're also going to do the same for s plus 3. You're going to equate it to minus 8 minus 18. So you bring this minus x to this side. It's going to be what? It's going to be positive x. So 4x, if you bring this one to the left, it becomes 4x plus x. That's how we got this 5x. That's how we got this 5x. Then, if you bring this 3 to the right, it's going to be this 3, positive 3. If it goes to the right, it becomes negative. So it becomes minus 18 minus 3. So minus 18 minus 3, you get minus 21. That's how we got this negative 21. So you divide both sides by 5. Divided by 5, divided by 5. So it becomes x equal to minus 21 over 5. You get whatever in decimal number. Okay, you can leave it like this if you want, if you don't have a calculator. So x equal to 5 or you see it's like quadratic. You know in quadratic you get two answers. So in modulus also you have to get two answers. S equal to 5 or negative 21 over 5. Is that okay? So that's for that number. Now let's take a look at this second one. Now for the second one we have the modulus of 2x minus 7 equal to 9. So what do you say? See, the modulus of this number 2x minus 7 equal to 9, meaning we're going to say 2x minus 7 equal to 9 or 2x squared. Okay, 2x squared, not 2x. So you're going to say, I started again. You're going to say 2x squared minus 7 equal to 9 or 2x squared minus 7 equal to negative 9. So you're going to have two conditions. We're going to have two conditions. 2x squared minus 7 equal to 9 or 2x squared minus 7 equal to negative 9. Because modulus, the result you're supposed to get for it, the original result that gave rise to the modulus must be positive or negative. So in the first scenario, you use the positive. In the second scenario, you use the negative. You keep this number, the one that has the modulo brackets or the modulo lines, you keep it same. But the number you say is equal to, you use one as positive, you use the other one as negative. Use one as positive, use one as negative. So now let's solve this. So you bring 7 to meet 9, it becomes positive. You move 7 from the left to the right, it becomes positive. It becomes 9 plus 7, it becomes 16. So 2x squared equal to 16. So you divide, because we're going to look for x, you divide both sides by 2. So you say 2x squared divided by 2, you get x squared. 16 divided by 2, you get 8. We get 8, right? So we get 8. So we get s squared equal to 8. So what we're going to do, we're going to find the square root of both sides. Take square root of both sides. However, in additional maths, most of the time we don't use calculator. So 8, you use solve to solve it. You know, 8 simply means, if you want to use solve, it means like this. You know, you are taking square root of both sides. So 8 simply means root 8, right? Root 8 is, okay, root 8 is what? 4, root 4 times root 2. Root 4 times root 2. Each of them carry root. Root 4 times root 2. Right? Root 4 times root 2. That's the meaning of root 8. You just break root 8 into 2. It becomes root 4 times root 2. Right? Now we have what is square root of 4? We get 2. Square root of 4, we get 2. So you just say 2 root 2. 2 times root 2 means 2 root 2. So if you don't want to use calculator, you can leave. You don't want decimal in your answer, you leave your answer as 2 root 2. So you're going to say anything square root, you know, you're going to have plus minus. So you're going to write plus minus 2 root 2. Why? Because the square root of 4 is a 2 that negative 2, if you square it, you get 4. And 2, you square it, you get 4. So that's why you have to use the plus minus. Okay? So the solution for this is plus minus 2 root 2. Now let's go to the second one, where we use negative for the modulus. 2x squared minus 7 equals to minus 9. So we're going to bring this minus 7 to this side. If you bring minus 7 to the right side, it's going to be minus 9 plus 7. It becomes plus. Minus, when it goes to the right, becomes plus. So it becomes minus 9 plus 7. So minus 9 plus 7 becomes negative 2. Negative 9 is like you're owing someone $9, and you now got $7. If you pay off, you still owing $2. That's the meaning of negative 2. So 2s squared equal to negative 2. So divide both sides by 2 so that you can find x. So you get s squared equal to negative 1. If you divide negative 2 by 2, you get negative 1. So x will be the root of negative 1. The root of negative 1. So that's the answer for this one. Is that okay? So this is how we do modulus, and you pause the video, you share, you subscribe, and solve all these questions. If you want to be good, you have to do a lot of questions. Like, take a look at this, s squared minus 4 equal to 5. So if you want to solve it, you say s squared minus 4 equal to 5, or s squared minus 4 equal to negative 5. So you solve both. Is that okay? You solve both. So all of the questions here, they are very easy. You pause the video and solve them. Is that okay? Okay, for this one, I think we just plot the graph. You find the value, they give you the value, the equation for the y, and find the corresponding values of y after you've chosen your domain. These are your domain, negative 2 to 4. And find the corresponding values of y, and then you plot the graph. So this is very easy, plot the graph, okay? So find the values of y and plot the graph. Now let's go to 1.6, which is the inverse of inverse function. So with this, today we will round up this chapter, and then we'll be going to simultaneous equation, which is chapter 2 of this additional maths. Okay, now the inverse function, what is inverse? We're looking for, like, inverse is like you're looking for the reciprocal that has been put in index form. If I say the inverse of x is going to be 1 over x, which is x raised to the power minus 1, right? So it's like the opposite, the reverse way. Okay? Now let's take a look at an example for inverse function. Let's take a look at an example. We have f of x equal to x plus 3 squared minus 1. Okay? We have f of x equal to x plus minus 1. Now, it's a final expression for the inverse. Okay, for inverse, there are three rules we need to know if we want to do inverse. So the first rule is that we should replace f of x with y. You know, the f of x they wrote for you, you should replace it with y. Use y to replace f of x when you want to solve inverse function. Okay, that's the first rule. Okay, that's the first rule. Replace this one with y. There are three rules. Once you know the three rules, you can do inverse function. The second rule is that we should interchange x and y. Interchange. Okay? Interchange. So I will not be able to type it with this, the way this is like this. So I'll just write inter x and y. I'm going to show you what I mean by that. X and y. Interchange x and y, and then the third one, make y the subject. Okay, make y subject. Make y subject of the formula. Okay, make y the subject. So if you do these three things, class, you will do your inverse. Now let's take a look at the function. F of x equal to x plus 3 squared minus 1. This is it. So the first thing we do, you see this f of x, we go to replace it with what? With y. That's the first rule. Replace f of x with y. So we go to write, in place of f of x, we go to write y. So we're going to say y equal to x plus 3 squared minus 1. You see? So we replace the f of x with y. That's the first step. The next step, interchange the position of x and y. You see here that x is, I will write y here. You see here that y is, I will write x here. Interchange their position. Here, I will write y. So it becomes here, the first one, it becomes instead of y, I write x here. Equal to, in place of x here, I put y. Interchange their position. Switch their position. Whatever language you want to use, switch their position. Here is y, write s in place of it. Here is x, write y in place of it. Don't change any other thing. Leave everything same. You say, so here instead of x plus 3 bracket square, you say y plus 3 bracket square minus 1. Every other thing is same, except you just interchange the position of x and y. You switch their position. Okay, that's it. It's just like normal in the classroom. Two students switch their seats. So you just switch their seats. That's what you did. Then the next thing is to make y the subject. So if you want to make y the subject now, first I will move this minus x to go and join minus 1 to go and join the x, to go join the x. So when it comes to the left, it becomes plus 1. So that's how we got x plus 1. So this x plus 1, you bring the minus 1 here. It's normal. Now it's normal in arithmetic. Now on the right, what we have is y plus 3 square. So we have to eliminate the square so that we can make y the subject. To do that, you have to take square root of both sides. So if I take square root of my left side, of my right side, if I take square root of the right, the square root will cancel square. Square root cancel square. Then I take square root of the left side also. So that's why you see here, root x plus 1. The square root will cancel the square. So you now have only y plus 3. So you know you want to make y the subject. So you now move 3 to the left. So it becomes what? Y will be standing alone on one side. Y will be standing alone on one side. Y equal to x, and the square root of x plus 1 minus 3. Because you move this one to join this place. Become minus 3. So when you reach here, remember y was just an assumption. Remember to replace it back with f of x. You see, y is no longer the y you had before. Look at the y you had before. Y was equal to x plus 3 square minus 1. Look at what you have now. Y equal to the square root of x plus 1 minus 3. They are two different things. It therefore means this new y that you just obtained is the inverse. Is the inverse. So you replace this time around, you don't replace it with f of x, but you replace it with what? F inverse of x. F raised to power minus 1. You replace it with f raised to power minus 1 of x equal to the root of x plus 1 minus 3 equal to this one. So you just replace this new y that you made the subject, replace it with your f raised to power minus 1. Once you do that, then your problem is solved, and you found the inverse of the function. So this is the inverse of the question that we were given. Now the B part of the question says, the inverse we just obtained, you should equate it to 3. You know, we just solved the inverse. You say f inverse of x equal to 3, meaning this whole equation you got, the square root of x plus 1 minus 3, you should equate it to 3. So you write it, in place of f of x, write what you just got, the inverse function you just obtained. So you say the square root of x plus 1 minus 3 equal to 3. Then you move this 3 to go and meet the 3 on the right. It becomes plus 3. So it becomes 3 plus 3, which becomes 6. And then you have root x plus 1 square root. Okay? To remove the square root, you square both sides. You square the left, you square. You know, if you have square root, to remove it, you square. If you have square, to remove square, you square root it. It's vice versa. If you have square, you want to remove square, you put root. You take the root of both sides. If you have square root, you want to remove it, you square both sides. Now, since we have square root on left, to remove this square root, I have to square my left, and I have to square my right. So it means this one square. You can put bracket first before you put the square. And also you have to square the 6. Means 6 square. Because whatever you do to the left, you must do to the right. Whatever you do to the left, you must do to the right. Okay? So 6 square. So this square, we cancel this square root. The only thing you have on the left now is x plus 1. And then when you square 6, you get 36. 36. So you move this plus 1 to the right, it becomes 36 minus 1. So x is left only on the left. So it becomes 36 minus 1 is 35. So x equal to 35. So that's your solution for that. Okay, so I think with this, we've come to the, okay, before we come to the end, is the graph of the inverse function. The inverse is just, if, for example, take a look at this line. If this is your f of f function, the inverse will just be this opposite way, similar, but just in a different way. For example, if you draw a line from the origin, which is y equal to x line. If this is my function f of x, this one, this line, the blue line, then my inverse will be this red one of the blue one. Okay? So the inverse function is not too far-fetched from the original function. It's not too far-fetched from the original function. Do you understand? Okay? So let's say, for example, if this is your f function, the inverse will simply be what? The inverse will simply be maybe something like this. The inverse will simply be something like this. The one that complements it, that makes it complete, that makes it quadratic. Okay, I'm trying to get a smooth one like the first one, but it's not so smooth, but you understand what I'm saying. Okay, so this will be the inverse. This is the original function f of x, this will be the inverse. You understand? Something that complements. Similarly, look at this graph. Look at this graph. This line, this one, this f function, this is the f function. The inverse will simply be this one, finish. This red one that complements it. Is that okay? So you don't have to worry too much. So with this, we've come to the end of today's class. And we specifically thank you for joining us. Okay? Thank you.